David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Today's topic covers standard or general form for a linear equation. These two words are interchangeable. So you might see it called standard form, you might see it called general form. They mean the same thing. So first off, to review, we have two forms so far. We have gradient intercept form, y equals mx plus b, and we have point gradient form, which is y minus y1 equals m times x minus x1. So you're going to need to understand these forms to get into some of these types of problems. So let's take a look at general form, standard form. ax plus by plus d equals 0. So a little different. We don't have the same kind of things going on as in these two forms. Check this out. A, b, and d are elements of the set of integers. So no fractions. So a standard form equation for a line might look like 6x minus 2y plus 10 equals 0. That's what a standard form equation for a line would look like. We have an x and a y, and we have our constant. We have them all on the left side set equal to 0. And notice how there's no fractions in here for my coefficients. So that's an example of a standard or general form equation for a line. So let's go ahead and make some. Here's a problem for us. Find the general form equation of the line with gradient -3/4 and passes through the point 0, 2. Okay, so we don't have a plug-in with this information and this form. There's no place for slope or gradient. There's no place for an intercept or anything. So we can't just take this information and plug it in here. Not going to work. However, if you notice something about this information, there is a form where we can plug in. Pause the video real quick and see if you can find that form and do that plug-in. So check it out. I have a slope and I have the y-intercept. So that would be gradient intercept, y equals mx plus b. So I can just plug in. Here's my m. My gradient is -3/4. My intercept is 0, 2, so it's plus 2. So there's my gradient intercept form of my equation. Now I need to take it from here to here. Now if you're feeling bold and you trust your algebra skills, pause the video right now and do that. I'm going to walk you through it. So the first thing for me is to get rid of the fractions. We have no fractions, only integers here. So this equation has a 3/4 in it. So the best way to get rid of that 3/4 is to multiply the entire equation on both sides by 4. So I'm just going to multiply by 4 on both sides. And what I get is 4y equals minus 3x plus 8. So that canceled out that 4 there. I have my minus 3x, and 2 times 4 is 8. So now I'm looking a little better towards getting it up to general form. In fact, here's what I need to do. I just need to get my 3x over and my 8 over and leave this side equal to 0, and I'm good. So I'm going to add 3x to each side, subtract 8, and see what we get. So I'll have 3x plus 4y minus 8 equals 0. And there you have it. Let's do another one. This time, I'm going to tell you the slope, the gradient, it's -1/2. And now I'm telling you it's passing through the point 3, 6, not the y-intercept. So you're not going to be able to get into that with a plug-in step on this form. You're going to need to use that form for your plug-in step. So go ahead and pause the video and do that plug-in. All right, I just did my y minus y1, which was my 6, equals the m, which is -1/2, times x minus x1, which is the 3. So there's my plug-in step. Now go ahead and use what you learned in that last example to go ahead and convert this point-slope equation into general or standard form. All right, let's walk you through that. To get rid of the half, I'm multiplying each side by 2. So I get 2y minus 12 on this side. The multiplication by 2 cancels out my 2 on the bottom. So I still have my minus 1 times x minus 3. I move on down. I brought that down. I distributed my negative 1, changed the signs, and then moved everything over to this side of the equation. And I have x plus 2y minus 15 equals 0. Now, I want to talk to you about one more convention with standard or general form. I don't see this in the notes or in the textbook, but I've taught this for other classes, and they've had one more condition, and that's that the a has to be positive. So in both the examples we've ended up with our x being positive, the coefficient on the x term being positive. I'm not going to mark you down on a test or a quiz, but I think that's a good standard to always have that be positive. I'd like to call your attention to something else that's a really handy trick with general or standard form equations. Not in our textbook, but it will come in handy when evaluating these things. So check it out. Here are two examples that we just did, and then I made one more up to help tease out the pattern. So what I've given you here, first example, we had a slope or a gradient of minus 3/4, and we ended up with that equation. The second example, we had a slope of minus 1/2, and we ended up with this equation. Finally, this one I just made up, we have a slope of 5/2, and we have this equation for that slope. So I want you to stare at this a little bit and see if you can figure out what the pattern is. Okay, check this out. Here's my A, it's a 3, and there's my B, it's a 4. 3/4. So M equals A over B. Let's test that. What we have is we have 3/4. Does that work all the way? Not quite. This is negative. So what it is it's negative A over B, and I can put my negative there, or I can put my negative on the 4. It doesn't really matter. It's negative 3/4. Okay? So the formula is this. If you have a general form equation, the slope or gradient is negative A over B, the A and the B from the general form. So check it out with this one. Let's do it this way. Negative A over B, so let's just do -1, that's my A, over B is 2. And that was my slope. How about this one? Tell me what the slope is for that. So I did my negative A over B, my B is negative, but I have two negatives here, so I can make this 5/2. So that's a positive 5/2. So in a way, you just take your A over your B and you change the sign. All right, let's talk about graphing from general form. Full disclosure, you can always pull up your graphing display calculator and put that in there, unless you are on the no calculator portion of the test, in which case your ability to build a hand graph becomes super important. I think these are really straightforward, so let me show you how it's done. Before we start, however, you should recognize that we looked at this function on the last board, and our slope was this, -3/4. So when we get our graph, it should be sloping down to the right. If it's not, we have a problem. So it's good to kind of know these things ahead of time so you can catch mistakes. So here's what we're going to do. First thing, move the constant over to the right-hand side. 3x plus 4y equals 8. Now we know some things about the intercepts. When the graph crosses the x-intercept, the x-axis, the y value is 0. So we can find the x-intercept just by setting y equal to 0. So set y equals 0. I'm going to write find x-intercept, because that's what we're doing. Set y equal to 0. So I have 3x plus 4 times 0 equals 8. Once we plug in our 0, this goes to 0. We get 3x equals 8. We divide by 3 on both sides. I'm going to get x equals 8/3. So this becomes the x-intercept. This is where the line crosses the x-intercept. And so that's going to be 8, 3, 0. So now we have 1 point. This is a linear function. All we need is a second point, and we can graph this. So let's use the same thinking. We're going to find the y-intercept. Find y-intercept. We set x equal to 0. Pretty straightforward. I'm going to do my plug-in. 3 times 0 plus 4y equals 8. That goes to 0. 4y equals 8. Divide both sides by 4. I get y equals 2. So that gives me a y-intercept of 0, 2. So now I have my two intercepts. I can just go and do my graph. So here's my graph. My y-intercept at 0, 2. My x-intercept at 8/3, 0. Draw my line. Shazam! Now let's go back to our slope. Our slope is -3/4. We are indeed going down to the right, so I think we're good to go. If you wanted to count out on your graph to confirm that that slope is correct, you would find that it was. One last topic, finding intersections of lines. So there's two main ways I want to show you how to do that, algebraically and then with your graphing display calculator. You can also do this with a hand graph, but you have to be super accurate and correct to be able to read the intersection off your axes. So I don't recommend that way to do that. So first, algebraically, here are two functions, two linear functions, two straight lines. So we want to find the point where they cross. We know they do because they don't have the same slope. If they had the same slope, never cross. But they don't. They will cross somewhere. So what we have to remember is that they cross. The y and the x values are the same for both functions. So they're going to cross where y and y on this side is the same. So if this is the same, say 4 or -7 or whatever that point of intersection might be, then we can set these two equations equal to each other and solve for the x coordinate of the intersection point. So let's do that. Minus 3x plus 1 equals minus 5x plus 3. Now, I know you have the algebra skills to solve for x, so practice. Pause video and do that. Okay, so here's what I did. I combined my x's on the left side, I combined my constants on the right side, divided through, I got x equals 1. So that's the x coordinate of the intersection point. Now see if you can figure out how to get the y coordinate. Okay, so what you do is you just take the x coordinate and you plug it in for x in either one of these two equations, and if you've done your work right, doesn't matter which one, you're going to get the correct y coordinate. So go ahead and do that. So just to test that, I did it both ways. I took my 1 from here and plugged it into this function and got -2 out. I also took my 1 and plugged it into this function right there. I also get -2 out. So that's a nice handy confirmation that I did my math right. So here is my point of intersection. All right, now what I want you to do is get out your graphing display calculator and put these two functions in and then use the calculator to notice and find out what that point of intersection might be. All right, here's my graph copied over from my calculator, and I did the draw the graph, so I did a very full graph with labels and points labeled and things like that. Here's my point of intersection, 1 minus 2. I scaled my axis to show that. Obviously, I didn't quite scale my axes the same, but it's going to be okay. I also noticed from my calculator that the y-intercepts are 0, 1 and 0, 3. So I put those on there. I labeled my functions. I labeled my axes and so on. So that's a very completely drawn graph of these two functions showing their intersection point. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.